Okay, hello everyone and welcome to another Ionic video. In this video I want to do a bit of a walkthrough of doing some creative performance optimizations of a component. So we're going to take a look at a performance profile and highlight some areas of concern of where the animation or interaction isn't performing as well as it could, or at least as well as we want it to. And then we're going to look at how we might address that in a situation that I think is a little bit perhaps not obvious, and the solution itself is a little bit creative. So we'll be comparing two examples. What I have up on screen now is one of the projects from my Advanced Animations and Interactions with Ionic book. So I'll link to that in the description if you want to check that out. But the general purpose of this project is to integrate a custom component we make called App Swipe Actions, and basically it's similar to a sliding eye on item in that we can sort of grab an item and move it around the screen a bit. But what happens is that, say if we just drag it a little bit like this and we release it, it'll just pop back into place. If we drag it a little bit more and release it in this sort of range, it will trigger an archive action. Or if we drag it even further, now it will trigger a delete action. So this is a custom component we made, and you can see it working here. If I let that go, it animates away. And if you are paying attention, maybe you might have noticed that the animation itself looked a little bit stuttery. It might be hard to tell on the video, but there is some noticeable sort of jank there. It's not particularly bad, but it's also not great. So this is the kind of first version of this application that I created, which usually just means, I'm doing everything just the way that first comes to mind in the most simplest way that I can think of. And then from there, I sort of measure the performance and see if there is room for improvements. And with this animation, I figured there would be room for performance improvements because we are using height to animate this item away here. And I don't want to delve into a whole performance tutorial in this video, but in short, animating transforms and opacity is good, it's cheap, the browser can execute it easily. Animating things that cause browser layouts, like height, is generally very bad for performance. So since we're animating from, let's say around 50 pixels to 0, we're causing these browser layouts as the rest of the items need to shift up the page. So with that explanation out of the way, let's give this a refresh, and what we're going to do is create a performance profile just to sort of verify our suspicion that something is a little bit iffy here and we're not really getting very smooth performance. So what I'm going to do is just record a performance profile. So in the Performance tab in Chrome DevTools, hit that record button, and what I'm going to do is just delete a few of these and do an archive there. That should be enough. And now we can inspect what is going on. And I'm also not going to spend too much time explaining this performance profiling either, just because a lot of this stuff is, takes a lot of time to explain in itself. We're just going to focus on the specific performance optimization that we will be doing for this example. So if I look at, say, around here, for example, we can see on this the green bar here, we've got some frame drops going on. These sort of dips on the green bar there means we've had some slow frames. And we need to achieve around 60 frames per second to get smooth performance. And we can see some frames here are dipping below that. Now in this range still, the frames we're getting here aren't that bad. If I did this test a bit more, I might see some worse frames and get more of an average result. But the result we're seeing is it's pretty good overall. It's not ideal with these sort of slow frames we have here of around 30 frames per second, but it's also not terribly bad. But an important thing to keep in mind is that we are testing on a reasonably high performance browser. So another good thing to do here is to set this CPU setting here. So if you click this little cog icon in the corner there, we can open up some additional options here. I also like to disable JavaScript samples to simplify this main thread a little bit. Generally, you don't need all that extra information, and we'll have a look at that in a moment. But we can set this CPU to 6 times slowdown. And so what that's going to do basically is slow the CPU down 6 times. And the CPU is generally what's responsible for performing most of our tasks in rendering to the screen. So if we have a slower CPU, generally the browser can't do as much work and it's going to struggle to get frames out. And so that just means that any performance issues that we do have are going to be much more obvious with that 6 times slowdown. So let's just clear all that out. We'll give this a refresh again as well to start from a clean slate. We will start that recording again, and let's again just get rid of some of these items. And we'll stop. And you can see now that we have a much more ugly picture to look at here. And this might depend on how familiar you are with these performance snapshots. But if we look at these green bars here, again, what we want is for those green bars to generally be at the top of this range. And if they are, that means we're getting about 60 frames per second, which is good. But we can see just from a quick glance that there is a lot of dips all the way along here. So if we just go into one area, we can highlight this area, for example, which looks pretty bad. And if we scroll along on these various frames, we can see we've got 26 frames per second, 23, 22, 19, 8, and 17 there. Then we have some good frames after that. So just 1 or 2 frames that are below that sort of 60 frames per second usually, can slip under the radar and won't be noticed. But when we have a long run of slow frames here, it is definitely going to be noticeable. So that's the problem we're facing. So how do we go about fixing this? I'll just quickly show you the actual animation that's happening here. So it's called host delete animation, and we're animating the height from 48 pixels to 0, and that's what is shrinking that item away. Now that's the effect we want. We just want to achieve that in a more performance-oriented way. And usually that means we'll use a transform instead of height or whatever else. But it's not so easy in this case because we can't just use transform to get rid of this, because we want the rest of the items to shift up as well. So let me just give you a little example of what I mean. So if I inspect this, for example, let's get our parent item there. So if I add, let me just add a height to this. So say 40 pixels. So it's already sort of shrunk away a bit there. So if I change this height, you can see as I change that height, it is shifting the rest of the items up and down, which is giving us the effect that we want of it sort of the list collapsing in. But let's say if I tried to use a transform, I might initially think, well, I can use a transform of a scale, for example. I could scale Y, and that's going to be much more performant. So if we scale, we start at, say, 0.9, for some reason that's being overwritten by something else, but so I've just added the important tag there to demonstrate, but I'd like to go in smaller increments if I could, but it's being a bit awkward for me. So I'll just do this manually. So if I at 0.9, it's going to shrink a bit down to 0.7. You can see that it's kind of getting squished away, and we could make this a bit nicer by changing the transform origin or something to make this a little bit more convincing than it is currently. But the main issue is that as I scale this, it still occupies all its original space on the screen, and all the other items just stay where they are. And then when we eventually delete this, then all of the other items are going to pop up or shift up when we remove it from the DOM, but that's not going to be animated. We're just going to get this quick popping into place, which again isn't what we want. So we seem to be at a bit of a roadblock essentially. It's like, well, we want the items to animate up, and to do that we're going to have to use height. If we use a transform, we're not going to get the effect we want. And sometimes that might be the case. There might just not be a way for you to do what you want with a transform. But in this case, there is a creative solution, and we're going to take a look at that now. So what I'm going to do is get the good version up on the screen now. I'm just going to take a look at that first, and we're going to see how much better it's performing, and then we're going to look at how it's achieving that. Okay, so I've got the good example up on the screen now. This is the sort of final version of the application. It's more or less the exact same thing. We're using the same custom component. and we're still having that height sort of animation going on. We can see all of the items sort of smoothly moving up the screen. But the difference is we're not animating height anymore. We're using a transform. And after all that explanation of why a transform isn't feasible in this case, I've gone ahead and said, well, now we're using one. But we're doing it in a very creative way, and I'll show you that in a moment. But first, let's look at the performance of this. So once again, let's get everything refreshed. We'll start with no throttling on the CPU, and we'll take a look at that, and then we'll do it with the throttling as well. So let's start this record. We'll just delete a few items, archive a few, stop it. And the sort of initial graph is, pretty standard. It's not all that much difference really to the no throttling version of the initial one. If we look at these frames, we're generally getting around 60 frames per second. And there is like a little dip here, for example. We can see that it's like one slow frame there of 43 frames per second, but even that, it's still maintaining a higher FPS than the other one. I think the other one was dipping to about 30 or so. And I think the cause for this little drop here, this is the point where the item is actually being removed from the DOM. There is a point where, although we're using transforms, there is a point where the item is actually deleted, it's removed from the DOM, and a layout needs to be calculated. So if we scroll into the task here to see what's happening, you can see that in this slow frame, we have a layout happening right here. Whereas if we look at the other frames, generally we won't see any layouts. We just see recalculate style, update layer tree, and composite layers. So this sort of layout here in this slow frame is a little bit unavoidable, but the important thing is that it's happening after the animation. So in the situation where we're getting rid of heaps at once, we're quickly swiping, there may be cases where that slow frame overlaps the animation. But if we're just deleting an item, that slow frame is happening after the animation finishes, not during it. So in a lot of cases, you won't even experience that slow frame at all. So now let's try this again. Let's clear everything out again. We'll try it again with the throttling and see if we're still maintaining a decent performance even with that 6 times slowdown. So let's enable that, start recording, and again, we'll delete a few of these items. Just delete 4 of them and stop that. And you can see, like with that 6 times slowdown, we are getting some frame drops here, but it is overall much smoother. So if we take this period, for example, we can see we start off with some pretty fast frames, 60 frames per second during the animation. And we still have fast frames here. We have like 1 slow frame there. So all of these are kind of, the slowest frame is around, we've got 28 there, but most of these are sort of 60-ish. And then we have, there's a couple of 30s in there. Let's take a look at this really low dip here to see how low we get. And that one's at about 28 frames per second. So but as you can see here, that is still surrounded by fast frames. And let's also just take another look at this initial one to see what we got there. So we have a slow frame in the beginning, then 38, 60-ish, got a 31 there, 70, 50, 34, 40, 50. So we can see with the 6 times slowdown, there is some noticeable frame drops, but I think not to the point where it will become noticeable to the user using the application. We can sort of, again, it might be hard to tell on the video, but you can sort of feel that it still feels quite smooth when you're using it. So we're still not talking about sort of ideal 60 frames per second constantly for the animation, but considering that we are getting this sort of height style animation at a pretty high performance, even with a 6 times slowdown, this is a really good result, I think. And so let's take a look at how exactly that is achieved now. So with the other version, we were just running this standard height animation, the item is deleted, or rather before it's deleted, we run this animation and then we delete it from the DOM afterward. If we take a look at the performance optimized version, what we're doing actually is in the actual component itself, we don't run any kind of animation to get rid of it. We just emit an event that says whether the element is being archived or deleted. and we pass along the host element. So this performance optimization kind of makes it a bit more awkward to use this component, but if you are kind of sort of pushing the performance in ways that are sort of out of the ordinary, sometimes you're going to have to sacrifice a bit of sort of code organization and cleanliness for performance. So where we are actually handling the delete for this is in the page itself outside of the component. And what we do is call this animate archive delete method. And we pass along the event and all the information that came with that to this method. And this is where kind of all the magic happens, I guess. So before it was just a simple animation was running. Once the animation is done, delete it from the DOM. Now we have all of this nonsense going on, basically. And so what this is doing, basically, is it is getting a list of all of the items in the list. So we're getting all the children from the list, basically. So we want a reference to all of these DOM elements here. Let me just turn this off so we can sort of come back and reference this. So I've got all of these elements in an array. And what I want to do basically is if I am deleting this element, what I want to know is where in the array that element is. And I want to take all of the items that are beneath the element being deleted, and I want to transform all of those up. So rather than shrinking the element itself, we're transforming all of these with a translate Y and shifting them up to cover the element that is being deleted. So let's take a quick look at how that works exactly. So basically I've just got this split on index. I'm searching through the list to see where the element that is being deleted is, and I keep track of that index. Then I create this array here of shift up elements. And so this is going to be an array containing all of the elements that are below the element being deleted or archived. And then I just calculate the height of the element that is being deleted, so we know how far we need to translate up. And then for each of those elements in that array, that is all of the elements that are below the element that is being deleted, we apply this translate Y here to shift it upwards. And we use just a transition of 0.2 seconds ease out to animate that change as well. We wait for that to complete, so we give it 200 milliseconds to complete that animation, and then we just call the handle archive delete method, which is just a method I already had to handle the actual deletion of that item from the DOM. And then once we've done all that, we want to shift the items back into their normal position now. So now that that DOM element is gone, we can, we don't want those items to still be translated up. We want them to be back in their normal position now, because their normal position now is in that moved up position. I think that sentence made very little sense, but basically, if I get rid of this initially, we translate all of the items up. But when that item is actually deleted from the DOM, which happens after this animation completes, these items would move up naturally anyway. So we remove their transforms, re-render the list to the screen, and the end result is, through all this trickery, is something that looks very much like the animation that we designed in the first place with height, but we do it through transforms instead. And I'm really happy with the end result of this component here, because we've made practically, well, we haven't made any sacrifices at all in terms of the vision for the animation. We're still keeping that shrinking height animation, but we've done it in a way that even under pretty high stress of a 6x CPU slowdown, it still maintains a very good frames per second. And if you wanted to push that even further, you could even make sacrifices to the exact way that the animation works. Sometimes that is what you'll need to do to maintain a really high performance. Maybe you need to change the way the animation works a bit. But for me at least, I think this is definitely within sort of acceptable limits for what we're achieving. Okay, so thank you for watching this video. If you enjoyed it, do feel free to leave a like and subscribe. As I mentioned, this is from my new book, Advanced Animations and Interactions with Ionic. So if you want to check that out, I'll have a link to that in the description. This example that we've been looking at is Ionic and Stencil.js, but there is Angular editions of the book as well. And depending on the time that you're watching this video, I also plan to release a React version as well. Okay, so again, hope you enjoyed the video, and I will see you in the next one.